Saime 4. gruppi, meil on 1 tüdruk, 3 poissi. Läheme praegu sööme ja me chillime, me läheme tagauksest.
Parem toit kui savakoolis. Kohe kindlasti.
Suurem valik, eks?
Jah. Juba see, et taimetoitu enam juures annab nii palju juurde.
Röd hake in Swedish and according to Google Translate, it's called like this in English. Is it correct? Yeah, you can get small flowers on this. It's a flowering plant, not a moss at all.
Kas ma peaks tõesti parem mõtlema küll?
Lugupeetud kolleegid ja õpilased, mõlema kooli õpilased.
So, dear colleagues and the students of both schools.
Täna oli väga huvitav päev, me õppisime palju, nägime tulevikku suunatuid ettekandeid.
We've had a wonderful day today and we've seen kind of interesting looking into the future programs.
Tahame muidugi tänada meie vastuvõtjaid ja kutsuda neid vastu külaskäigule Saue gümnaasiumisse.
We'd like to thank you, all of you, and invite you to our school.
Ja anda üle ka mõningad suveniirid, annaksin üle selle kooli teadusdirektorile. Siin on rahvariietes Eesti nukk ja ma arvan, et see sümboliseerib seda piirkonda, kus meie kool harjuma.
We would like to give you some presents for the school, and there is a doll in our full costume and that symbolizes the area that we are from.
Thank you.
And also
Oh yes,
says that.
yes. And we really like to participate in trips. Yes, I have to. Yes. Thank you.
Okay, so we have got some small gifts for teachers from Estonia too. And this is a bag and somewhere it should say Rudbeck. I don't know where it is though.
We have to show the bag.
Yeah.
This is Rudbeck.
Thank you.
Thank you very much. Thank you. So you will get a smaller bag.
Enjoy your shirt.
Enjoy and share. And it's made of organic cotton.
Te hakkate nende kottidega poes käima ja kilekotti ei osta? Unustate kilekottid ära?
Siiski tuleb siuke küsimus, et maailm on korralik ja katnud kotis, mul tekib kotti probleem.
Ja ma tean, ja ma ongi.
Ja. Thanks, Colin. I do like this, yes. Forte. Thank you. Like that. Stop.
Thank you. Meen je nu dat is stop?
Unit 1, 2, and Unit 3. And this is the water tower, which you've probably seen. It's the same building as us. And this is Unit 3, the biggest reactor in Sweden. Questions? Good, you all understand everything. Amazing, amazing. Now, the actual reactor is located here. And then you have the turbine there. If we remove all of the walls and things like that, it looks like this. So this is the reactor. This is the control room on the side. Steam is being moved over there into the turbines. And then it spins the actual generator, creating what we want, electricity. So that is the purpose, to spin that thing around. Not much of a business plan. What do you plan to do? Well, we plan to spin that thing around. So it is a complicated process, and you can just see by looking at it, it's not super simple. But it sort of is, actually. It's not that complicated what we do. Because we do electricity. Have any of you made an electricity? You've ridden a bike with one of those noisy generators. Then you've made electricity. If you've driven a car, then you made electricity. Because all you need to do is spin the generator, which is in every car or some bikes as well. A wind power plant is quite easy to understand as well. You have a generator, and then wind blows on the turbine blades and it spins like a propeller. Done. If you have a hydropower plant, instead of wind, you just use water from the river. And that's what we do as well. Except we make our own wind. We have the generator, we have the turbines, and the turbines are like the turbines of a coal power plant. Very similar to a wind power plant, except that they have lots of blades, and they are much smaller. And we have wind. But the wind is steam. And how do you make steam? Well, the recipe isn't that complicated. You just take water and heat it. And once it starts to boil, you got steam. What we do then is that we put a lid on it. And if you try to put a lid on steam and keep it there, it works for a few seconds. And then starts seeping out steam from the side. And that steam is what we trap and force it into the turbines, spinning them. And that's pretty much it. We boil water, push the steam into the turbine, they start to spin, and that spins the generator, making electricity and happiness. Now, however, there is a problem. Because we boil a lot of water, which means that we lose a lot of water. And here we have a lot of steam, which is completely useless. So we need to get rid of it. And here we need more water. So we solve this problem by cooling this water. The steam cools down, condensates, and turns into liquid water again. We use the sea for this. So we take in the Baltic Sea, cold water, which absorbs the heat, being pumped back. The steam has now turned into liquid. It hasn't changed temperature, which can seem odd, because it's 30 degrees, and then it's still 30 degrees. But this is the same thing when you boil water. It's 100 degrees all the time, until it's completely evaporated. So here's the reverse. The steam and the temperature has the same, the steam and the water has the same temperature because it's condensating all the time. Can't change temperature then. So we just take this water and pump it back in. And then we boil it again. We boil 1.8 tons of water every single second in one reactor. So we just take a Rootsi and just go whoom, 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 all day long in each reactor. So it's a huge amount of power transferred into this system. The temperature is about 280 degrees. The pressure about 70 bar or 7 megapascals. And that's what simply turns everything on. Did you get it? Congratulations. Now you know how every single power source works. Everything works this way. This is a hydropower plant or a wind power plant, depending on if it's liquid water or wind. It could also be a coal power plant if you heat the water using fire. The only thing you don't understand is solar power. But that's witchcraft. Just sun and get, I know it's strange. Oh, generators. Good stuff. Questions about the mechanics of the process or anything like that? Questions about anything else regarding something?
What do you do if any part of it breaks down?
Then we shut it down. If there is a mechanical failure, of course it depends how serious it is. If it's a small secondary pump, then you just turn it off and start the backup pump. And then you turn it to the service team and test it to make sure, oh, now it works. Test, test, test. Good, now this is the backup. If that starts to fail, just put this back on again. Because you have another backup and probably 2 or 3 of those as well. But say something serious happens. There's a rupture in the steam pipe. That's bad. Then the automatic system will detect that and turn off the reactor. And if it's really serious, it will shut down the reactor completely and isolate it. So these valves, they're like bigger than I can show you with my hands. They will just go and shut it down. So this will be completely isolated from the rest of the world. Which means that even if there's a pipe rupture, it doesn't matter anymore. Because there's no contact with the core. So then you can just fix it, test it, make sure it works. And the reason why it will take so long to start it again, you need to find out why it broke. Is there a mechanical failure? Have they failed to maintain it? There been an accident, how we can prevent that from happening. So if there's something serious, it's probably not fixing it that will take time. It's the investigation on how to make sure it doesn't happen again that will take time. And also once we have made that, we also have to make sure that authorities get a report and they will then do the same thing. So it's double. So that if we say, oh, we solved it, there's still an independent authority who will then authorize it. So we can't just fix things as we like. If we can't prove that it's safe, then we will not get permission to do it. So there's a lot of checking and testing and controls. Right, anything else?
How big is the lifespan of the reactor?
Well, at the moment, we calculate it will last 60 years. And it can last longer, but then you need to maintain it, and it will probably cost more than you can earn. So it's like an old American car. You can see that on the road shows and things like that. Super nice. Shiny, shiny. Brand new stuff, even though they're old. But that's a hobby. You don't have a nuclear power plant as a hobby. So you don't find those cars when you call for a taxi. You don't get like an old Chevy going on, hello. It's a Volvo or a Merc or something like that. Because there's no economy in it. So you could make it last longer, but it will cost way more. So 60 years for the new reactors, 50 for the older ones. So that's total running time. Yeah, if all goes well. Right, anything else?
So 50 years is the amount of time that there is to find alternative
Yes.
sources as well.
Yeah.
What's the time limit on that?
Or you could just build a new reactor. So we have lots of time if you want to. If it's carbon emissions we're worried about, then you can build nuclear power plants for hundreds of years. Not all power. I'm not saying we should only build nuclear power plants. Nuclear power plants have downsides as well. They're very, like, they don't like to be adjusted. It's like a tractor. They just go. They're very strong, but you don't like to oh, they turned on a light there and it's almost 8 o'clock. People go to bed. We'll lower production. The reactor will go. No. I prefer to just keep going. So in Sweden, nuclear power plant goes at 100% all the time, and then we save hydropower. Hydropower plants are very easy. You just shut the gate. No water, the turbine stops spinning. The next morning, you've saved all of that water. A reactor, well, everything is still here. It doesn't cost anything extra to run it. Buying and maintaining it is what costs money. Uranium is dirt cheap. It's like less than 10%. So we'll lose like 0.2 euro cents per kilowatt hour. That's the extra cost of running it compared to not. What I'm saying is if we turn it down, we lose 10 million Swedish crowns. That's more than 1 million euros a day. We don't want that. So we say water for hydro plants instead. Questions? Anything else?
Yes, so if you want to see animals, you can, it's on the other side. And here we have, i det här stadskvarteret, this is kind of old city houses. And in the middle here, it's old houses from the countryside in Sweden, from different ages.